All right, this is Unit 1 Review Day 1. From this video on, everything is optional, so it's not mandatory for you to do these assignments. It's all extra credit from this point on because we have gone over the whole unit at this point, okay? So, for Unit 1, we did a lot of review of what you've done in past math classes. So, this is kind of a review of review. So remember, the first thing we talked about was function notation. So like, for example, number 1 says f of 1 plus g of 3, which means f of 1 tells me I'm going to plug in 1 in my f function everywhere I see an x. So that's going to become, so for f of 1, that means that's going to become 1 squared minus 5 times 1 plus 1. And so when I do that, and notice everywhere I'm plugging it in, I'm putting parentheses around it. So 2, bless me. And that becomes negative 3. And so then for g of 3, I'm going to plug in 3 into my g function, which is going to be 2 times 3 minus 1, which is going to be 5. And so it tells me to do f of 1 plus g of 3. So I'm going to take these two numbers and add them together so that my final answer is positive 2, because negative 3 plus 5 is 2. Okay? So same thing goes for number 2, except for this time we're going to take those two numbers and divide them. So with h of negative 2, everywhere I see an x, I'm plugging it into the h function. So that's going to become negative 2 to the 3rd power minus negative 2 squared plus 4 times negative 2 minus 7. And this is an example of why it's important to always put these variables or these letters, or not letters, numbers in parentheses, because here you have a minus negative 2, and that's going to mess you up with your signs. And also in the calculator, it messes up because if you don't put parentheses around this thing, the calculator will think you're doing 2 squared and then putting a negative out front, versus what it's really doing is negative 2 as a whole squared. So it's going to change your sign of your number or your answer. So negative 2 to the 3rd minus negative 2 squared plus 4 times negative 2 minus 7. And that gives me negative 27. And then with g of 5, I'm going to plug in 5 into my g function. So 2 times 5 minus 1, which gives me 9. So we take those two numbers and we're going to divide them. It's going to be negative 27 divided by 9, which gives me negative 3. And that's my final answer there. Okay, now this one tripped up a lot of people. This one says f of g of 4. So what this is saying for f of g of 4, you're going to do g of 4 first, okay? And whatever we get for g of 4, we're going to replace right here. Okay, so for g of 4, that becomes 2 times 4 minus 1, which is 7. So this 7 is going to replace this whole piece right here. So that's going to become f of 7. And so we plug that now, our new number, into our f function. So that becomes 7 squared minus 5 times 7 plus 1. So 7 squared minus 5 times 7 plus 1 gives me 15, and that is my final answer. So you always plug in what's on the inside first, then take that number and plug that to the outside function. All right. Number 4 says f plus h of x, which basically is the same thing as f of x plus h of x. And notice I don't have any numbers in here to plug in for x. We just have x, which means that what we're going to do is we're going to take our f function, x squared minus 5x plus 1, and we're going to add our h function, which is x cubed minus x squared plus 4x minus 7. And so what that means here is we're going to combine our like terms. And so x cubed is my largest exponent, and it doesn't have a like term, so we just bring that down. We've got x squared and minus x squared, so they're going to cancel out. And then we've got a negative 5x and a positive 4x. So when we combine our like terms there, that's going to give me negative 1x, or just negative x. And then 1 and negative 7 is going to give me negative 6. So our final answer there is x cubed minus x minus 6. So whenever it tells you to add those two functions and there's no number inside, you would just combine the like terms. If this said f plus h of 2, then you would plug 2 into both of those and then add it together. But because we don't have a number to plug in, that means we just combine our like terms of our functions. All right, so the similar goes on for f times g of x. That's the same thing as f of x times g of x. Okay, and my f function is x squared minus 5x plus 1. And we're going to multiply our g function, which is 2x minus 1. And there's two different ways you can do this. You can do box method or FOIL method. I always do box because box method keeps me from forgetting to multiply anything and making any mistakes. So we've got x squared minus 5x plus 1, and then 2x minus 1, and we start multiplying. So that becomes 2x times x squared, which is 2x cubed. 2x and negative 5x is negative 10x squared. 2x and 1 is 2x. Negative 1 and x squared is negative x squared. Negative 1 and negative 5x becomes positive 5x, and then negative 1 and positive 1 is negative 1. And so once we have our box filled out, then we just combine our like terms. So we've got 2x cubed. My x squareds combined to give me negative 11x squared. And my two x's combined to give me positive 7x minus 1. And that is our final answer there. Okay. So that was the first thing that we talked about in Unit 1 was function notation. After we talked about function notation, we then talked about domain, range, positive, negative, increasing, decreasing. And remember, we talked about a bunch of different ones, and this is when I started color coding. So I'm going to use a couple of different colors in my notes just as an FYI for in case you're trying to take these notes as well, okay? And one big thing that we always talked about was brackets and parentheses. Remember, brackets are used when the point is included. And most of the time when the point is included, that means that you have a closed circle. Or the line just goes straight through that point. And so that closed circle is when we're plotting a point. So like, for example, on this graph, if this had been a closed circle here, you would count that as a bracket there. Okay? And then parentheses are used when the point is not included. And so there was two different times that that would be accounted for. And so that's when you have an open circle or infinity, sorry. So if your graph goes to positive infinity or negative infinity, that's when you use the parentheses, okay? So with domain is all of the x values. And remember, to find the domain, you always look from left to right, okay? We don't even look at our y-axis there. We start from left all the way to the left. And so notice my graph here for this example is going forever and ever and ever to the left. So that means it's going from negative infinity and then all the way to the right. My graph is still going to keep on going forever and ever positive. So that means that it's going to positive infinity. Now say, for example, this one had stopped right here. That would have been negative infinity to 7 because that's my x value right there. So that's when you have to be careful. So if this had been, and it doesn't matter that with domain that my arrow is going up or down, okay? It's still going to the right, which means it's going to positive infinity, okay? So then range is all of my y values. And so that's when you look from bottom to top. Okay, always start from the bottom of your graph and then all the way up to the top. So from the bottom of my graph, again, I still have that arrow going down forever and ever. So that means it's starting at negative infinity and going up, looking at the very top of my graph to positive infinity. Now say again, for example, say we just had this piece right here, okay? It's going from here to this peak right here. That would have been negative infinity up to 1, 2, 3, 4. Because it stops there. It doesn't go any farther up. So that's just an example whenever it's not both infinities, okay? So that was my domain and range. And then we had increasing and decreasing. So increasing is the x values when your graph is going up from left to right. And then my decreasing is my x values going down from left to right. And we always start at the far left and read our graph going left to right. And so what I mean by that is, so remember we talked about it, looking at it like a roller coaster. So notice from left to right it's going down, then up, and then back down. So that's decreasing, increasing, and then back decreasing. So I'm going to start with my decreasing, okay, going from left to right. It's going decreasing this whole entire time right here. And I have an arrow all the way to the far left. So that means from negative infinity until I get to this point right here, it's decreasing, which is at -6. So from negative infinity to -6, I'm decreasing. So I'm going to put parentheses for negative infinity and then bracket for -6 because that point's included. Okay? But from there, my graph goes back up. So from -6 till -2 right here. And again, remember, I'm looking at the x values. I'm not looking anywhere on my y-axis here. From to -2, my graph is increasing. So it goes decreasing till I hit -6. Then it's increasing until I hit -2. And then my graph starts decreasing again. And remember, whenever it starts back the same thing, it's decreasing again, we call that a union. Okay, so it's going to start decreasing again from -2 until we get all the way to the end and we see an arrow, so that's going to positive infinity. And your graph should always start with your increasing and decreasing. They should make a whole entire line from beginning to end. So notice negative infinity, -6. Then this one picks back up from -6 to -2. And this one picks up at -2 and keeps on going forever. Okay, so that's my increasing and decreasing. Domain, range, increasing, decreasing. Okay, and so then positive is my x values that are above the x-axis. And my negative is my x values below the x-axis. Okay? So again, we look from left to right. But remember, we're stopping every time we hit the x-axis here. Okay? So here, I'm positive. Let me make sure I got my colors straight. I'm positive from this end until I hit right here. So that's at negative infinity until I go to -7. Now here's where a lot of y'all had issues, because remember, this is right at 0. That's neither positive nor negative. So from -6 to -7, I'm positive, but at -7 you have to use parentheses. So with positive, negative, you're never going to use a bracket unless you have closed circles at one of the ends. That's the only time. And from there, we start going below the x-axis again. So we're below the x-axis here all the way until I come back up. So from -7 until I come back up at -4. So that's not two separate ones. That's one whole piece from -7 to -4 because it's still below the x-axis at that time. And again, I use parentheses for my negative. And then I'm positive again. So from -4 all the way up and then all the way back down until I hit right here at 2. From there to there, I'm positive. So that means that's going to be union -4 to +2. And so then back at +2, I go below the x-axis, which means I am negative again from 2 to infinity. Because my graph's going to keep on going on forever and ever below the x-axis. It's never just going to come back up all of a sudden. Okay? So that's a lot of different stuff going on. You just have to take it one piece at a time and think about it as you go. So remember, domain is all the x's, range is all of the y's. Increasing is when you're going up, decreasing is going down. Positive is above the x-axis, negative is below the x-axis. Okay, and then we also talked about whether a graph is a function, and that's when you use the vertical line test. And remember, the vertical line test means if I draw a line straight up and down at any point in my graph, if it hits my graph more than one time on that vertical line test, that means it is not a function. If I had only hit it one time forever and ever, that means yes, it is a function. Okay? And then the next part asks us to find the domain and range. So the domain is from left to right, and my graph starts right here from the left, which is at -7. And notice there's not a closed circle, but my line is continuous at that point. There is no open circle, so that is included. So that means it's a bracket, and then it stops all the way at the right until I get to +5. So from -7 to +5, and both ends get a bracket, that's my domain. Okay, and my range, this graph is just a little bit, because I was trying to do this by hand, is a little bit off. So my graph is technically supposed to stop up here and end on the next line. They're supposed to be on the lines. So here, from bottom to top again, remember, range starts from the bottom, which is at -1. Yeah, -1. And then it stops up here at +5. 1, 2, 3, 4, 5. +5. And we use brackets for that one as well, because there's no open circles, there's no arrows. That's the only time you use parentheses, is whether it's an infinity or an open circle or arrows. Okay, so that's my domain and range. The next one, for number 9, it just gives you a table for domain and range. Now here's where a lot of y'all kept making mistakes when it came to the tables. With domain and range, and it's a table, you literally list exactly what the numbers are. So for here, my domain is all of my x values. -2, 0, 2, 3. You do not list them like this with brackets and parentheses. You literally list every individual point. And you don't have to repeat 3, you just write it that one time. So you do not write -2 to 3 in brackets. You always have to list, because that doesn't tell, I didn't list -1 in there, I didn't list +1. So that's not included in those points. This is telling me all the points from -7 to 5, versus this one is talking about each individual point. So that's where a lot of people kept making mistakes. And then your range is all of your y values. So that's 5, 4, 3, 2, and 1. And again, you still don't use brackets. Just because it includes every individual point here, it doesn't mean that I'm including, what about 1.5 or 2.5 or 3.7? Those points aren't included there. So that's why you, again, whenever you're given a table, you list exactly those points that you're given. All right, and then it talks about telling whether the relation is a function or not. Remember, if it's a function or not, you cannot have repeating x's. Okay, just like here. Here, my 2 x's repeat because I have 2 different y values to them. So that means this is not a function because I have these 2 3s right here. If this had been 5, 5, 5, 5, 5, it's still a function because these are all different x values. Your y values can repeat all day long. That doesn't matter. It's the x values that can not repeat. All right. And so that is all of the Unit 1 Day 1 review. The next one, on the next video, I'll start talking about what we did on Day 2. I'm kind of like splitting the units in half for 2 separate days. For your classwork, for Unit 1, you're practicing your function notation for 1 through 4. Now, I don't know if y'all's graph didn't print out right, but mine did not. It shows up on the computer correctly, but for some reason, mine didn't give me all my tick marks here. So just real quick, this point right here is supposed to be at 1, 2, 3, and then 1, 2, 3 right there. So this point is technically at negative 3, 3, okay? And then it hits my axis at negative 5. So make sure you have 5 tick marks from there to there. And then it keeps going 6, 7, 8, 9. So this point right here is down at negative 9. All right, and then here, of course, that's 0, 0. And then here would be at 1, 2. And then the rest doesn't matter because you got an arrow from the rest. So you're going to list the domain, range, increasing, decreasing, positive, and negative. That's just a heads up. Oh, and you also need the bottom tick mark. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's at negative 5 here. Okay? And so then on the next page, you're just telling me yes or no if the graph is a function. So that's using your vertical line test. All right. And then that's the end of Unit 1 review, Day 1. So if you have any questions, comments, concerns, please feel free to message me on Remind or comment on the videos or on the group, Google Classroom. All right. Bye.